Last time we talked about the controllability for linear systems. Okay, so is this are these clear to everyone? So are these clear to everyone? Any questions? Okay, and is there anyone here that doesn't know what is full rank? Let's start from here. What is the rank of a matrix? I'm sure you have learned this in your undergrad in the engineering mathematics. Okay. Rank of a matrix means how many independent columns of a matrix. Okay, like what's the rank of this matrix? It's a 1, right? A. Okay, because there's only one nearly independent columns or rows, right? You can do Gaussian elimination. So if you do Gaussian elimination, you will get this, right? Right. So only one independent rows. So, and because this matrix is 2 by 2, okay, so any rank below 2 will not be full rank. Okay, full rank means this has to be 2. Okay, 有印象吧? So of course this matrix, this C matrix, which consists of BAB, okay, will be full rank. So if this system is a 3-dimensional system, okay, like 3 by 3, A matrix is 3 by 3, then you have to check out a 3 by 3 C matrix and see if the rank is 3. Otherwise, it's not full rank. Okay. This second example is dimension of 3. Okay. So the C matrix, which here is B, AB, and A squared B. And it's full rank, for sure. So this system is controllable. So it's still not clear. Okay, so you should be able to understand why we put B here, AB, and A squared B, right? But it's still a little bit not clear because it's hard to give you a physical example of this kind of system. So in the next topic, which is controllability for nonlinear systems, you will be more clear because it's more easier to give you an example. Okay. And the definition for nonlinear system is this f and g could be any nonlinear function of x. Okay, so compared to the linear system where it's ax and bu, right? A and b are constants which are not function of x. But now for example, in this affine system, the x and u are coupling together, right? U can change x dot, right? And x dot can change x, which can goes back to here, can change gx. So the gx at t0 is not equal to gx at t equal to 1, right? 对吧? But before, your B matrix, which is similar to this gx, is constant in a linear system, but here is not constant, it's a function of x. So here's an example for nonlinear systems. So there are 2 examples. So the first example, U1 is like the pedal of the car. You can control the linear velocity of the car, Okay. And the coordination, the coordinate system is global coordinate, which are or inertial coordinate. Okay, and this U1 is fixed. Is fixed on this vehicle. Okay, no matter how you steer in the car, this U1 is the heading angle, right? So in the first example, there's only one control input U1, okay, which is the heading velocity. In the second example, we add one more control input U2, which is the steering, or you can say angular velocity of this. Okay, so this you can change the direction of your car. So you can imagine that, so in these two examples, one is not controllable, one is controllable. So it should be obvious, right? This one is not controllable. But why? What is controllable? Controllable is we want to, in the linear system, I say if the state is x1, x2, and your control input is U, right? If you can find a way to control every state by this U, the system is controllable, right? So similarly in here, what are the states? The states are x, y, and theta, right? What is control? Control is U1, U2. So what is controllability? If I can give an external control to guarantee that this state can be affected by this control input or this control input, right? So in other words, if I can change the velocity or steering the car such that you can move to any x, any y, and any theta, right? So what is any x and any y? If I can accelerate and steering my car to move the car to anywhere in this x, y, z plane, any location in the x, y, z plane, that will be controllable, 对不对？听得懂吗？ Okay, so in this case, is that controllable? Not. Why? You cannot change your steering angle. That means that you can always go in forward and backwards. You can only drive your car anywhere on this straight line, right? You cannot move to the left or right or left, right? So it's not controllable. So in our view, obviously this one is controllable. So the next question, if you understand this, then the next question is there any systematic way to check that given the system, a nonlinear control system, and you can use that systematic way to say it's controllable or not? Okay. Here we are lucky is a simple example, right? But how about a more complicated system? How can you tell? So we will introduce that later. Okay. So here, as I mentioned, given a control input, right, you can change your derivative of states. Right, you can change your derivative of states, and as time goes, this x will be integrated. So the x is will be different from the previous time. And this x can change the gx, right, in time, delta gx. So the gx is not constant. So this control u can change x, can change f, and can change g. Everything changes. Okay, so it's very complicated. In this example, when you see a parking lot in the roadside here, you want to park your car, this one, to this roadside parking slot. How will you do that? If you can steer your car and change the velocity of your car. So what you will do is you first go here and rotate your car to the counterclockwise and move back and rotate clockwise. Then you are in this parking slot, right? So this combination of these are the combination of your control input. Here we use U1, right? Moving back and forth. Steering your car, moving back and forth, and steering your car, right? So these are a series of combination of your control input. So given this series, it shows that it's controllable in this case. So how can you do it in a more systematic ways? So let's go back to the slides. Here. So given a nonlinear system, okay, you can, here's a lemma called Lie bracket, and here's the definition, okay. And the definition is this y prime is the gradient of y with respect to x. X prime is the gradient of x, capital X, with respect to x, okay. And the physical meaning is this is the derivative of y along the flow joined by x. Anyone understands? You can say the change of y along the change of x. Okay, but unfortunately, x is changed based on these dynamics. 懂吗？这个是说，这个东西的意思是说，你根据这样算出来之后，这个意思是，我 y 会改变多少？如果我改变我的 x 的话，但 x 也不是随便改变的 ，x 必须遵守这个 differential equation，right？ 对吧？懂吗？这是 dynamics 嘛 ？Robot has its dynamics, vehicle has its dynamics. They are different, right? So they are expressed in different ways. So this motion is constrained. The motion of x is constrained. Okay. And this x could be g or could be f. Y could be g or f. For example, the controllability for the nonlinear system is taking you're taking care of all the brackets involve f or g. Okay, so here is one Lie bracket. Here is another one Lie bracket, and in which there is another Lie bracket. Okay, and so this will give you a column vectors, and you check if the combination of this column vector will be full rank. 懂吗？这个就看成有点像 B A B A square B, and you check if this matrix will be full rank. Okay, so I'll give you examples. This example is exactly the same. This example. Okay. So now, what is f and g in this system? So you can say the state x is x1, x2, theta, which is a column vector of three-dimensional column vector. And what is f? So how many control input here? 2, right? So you will have U1 and U2. And U1 and U2. Okay. So if that definition is okay, given x, what is f? Zero, 对不对? What is G1? G1 is the coefficient of U1. G1 is the coefficient of the first control input, which will be cosine sine 0. And G2 or B, what is the coefficient of U2, which is 0, 0, 1. Okay. Right? Sorry. Okay, so lead bracket. Let's try f and g1. And you can also try f and g2. So in this case, it's kind of special case of that one, because that one only give you one control input, right? But here you have two control input. But assume that you can only control the velocity, the heading velocity of the car, but not the steering velocity. Then you can eliminate this one, which give you only one control input, and that will be exactly the same as the system. But for two control input, it should be similar, and that should be fine, right? Is that okay to everyone? Okay, so let's try this. So what's this? According to the definition of this lead bracket. Okay, so the capital X layer will be F, and Y will be G1. So according to the definition, the right-hand side of the definition is partial of Y, right? And in this case, it's G1 times F minus F partial G1, right? Right. Okay. So what is G1 partial? It's defined as the gradient of G1 with respect to X, which is the state. Okay. And what's the dimension of G1? 3 by 1, right? And X is 3 by 1, right? So what will be the dimension for this gradient? Anyone knows? 这个是3乘1 G1 3乘1 X 3乘1 归点之后会变成几乘几？3乘3，哎，我听到谁说的？有人说3乘3，还是我心里面的声音？好，也会3乘3。OK， why is 3 by 3? if I teach everything on the class, we will be very well, we will be behind the schedule. But why is 3 by 3? Imagine that okay. G11. Okay. So this will be okay. Will be this. So as you know that gradient of G1 with respect to x times delta x will be delta G, right? 这样对吧? Gradient and you times some differential of x will be the differential of G, right? Agree, right? What's the dimension of this one? 3, right? 对吧? And what's the dimension of this one? Delta x. X is 3 by 1, R3. 3 by 1, 3 by 1. So it's clear this one had to be 3 by 3. 对不对? Right? We know this one is 3 by 1 and equal to a 3 by 1. The only possibility is 3 by 3. Right? Right. So this one had to be 3 by 3, which is this one. Okay. And why is x1, x2 theta? x1, x2 theta. x1, x2 theta because when you times some delta x, right? This one goes to the first column. So all these had to be x1. All these had to be x2. All these had to be theta. Okay? So what is this? It's required in here. So what is gradient of G1? So G11, 11 means that in G1 the first element. G12 is G1 second element. Okay. So G11 cosine theta, right? So cosine theta, cosine theta, cosine theta, which are independent of x1 and x2, so they will be 0, 0. What is cosine theta? Partial cosine theta with respect to theta, minus sine theta, right? And what's G12? G12 is sine theta. So again, 0, 0. Because they are sine theta independent of x1, x2. And this one will be cosine theta. And this is 0. G13 is 0. So it will be 0 for no reason. Okay. 这样有没有问题？这样没有问题。So, and what is F? 哪边有问题？哎，我怕我写错啊。这样录影存证，我写错这样不太好。有错吗？好。X2。这边就不写了。I skip these two. Okay, should be fine, right? So what's this? F1 is everything is 0, so it will be 0. Okay. So this one is 0. So G1 prime F will be, what is F? F is 0. F is 0, so it's 0. F is 0. So is that clear? Any question? No. If that's fine, let's see here. So we have try F G1. You might also want to try F G2, but because F is 0, no matter how you try, will be 0, will be 0. So you might need to try G1, G2 rather than put F in here. So for G1, G2, if you follow the same procedure, you will get sine minus cosine 0. Okay. So this D bracket generates the motion in the direction perpendicular to the orientation of the car. So what does this mean? So see, this one is perpendicular to G1. Okay. So this is the orientation of a car, and so this one is perpendicular to this. But what does this mean? This one means that if you use the combination of this G1 and G2, you drive and steering, you combine these two actions, you will obtain a motion that's called slide, like here. If you drive and if you use U1 and U2, okay, you can use the combination of this. You can move a car from here to here. It's kind of slide. Okay. So here is G1 and G2, which is the combination, the coefficient of U1 and U2. And you examine this, and you find a column vector which the first and second element are non-zero. That means that in these two states, the action, the series of control input can change these two states in this direction, depending on what is theta. Okay. And in this direction, it's kind of like you slice, okay, perpendicular the orientation of the car. Okay. Is that clear? Perpendicular to the orientation of the car. Originally, your orientation is here, right? But you can move in the perpendicular direction, which is this direction. So you move from here to here. 看清楚吗? Okay. So you can review all this material online in the Google site. So if you need more time, you can go back to check those materials. And remember that the Lie bracket means the derivative of y along the flow generated by x. Flow means the time derivative of x. Okay. Okay. And there are some more examples. Let's see. It's a similar dynamics compared to the previous one, except there's one more state. And again, you have U1 and U2. Again, it's the heading velocity and steering your car for U2, right? Because U2, which here is a non-zero element, which changes the time derivative of theta. Okay, so this U2 is for steering. This one is for acceleration. So G1 and G2 are the corresponding coefficients. So this one is for driving, this one for steering. So if you combine these two, you steer and you drive, you can generate a motion called wiggle. Okay, wiggle is kind of like a snake. You go around. Okay. And if you combine wiggle with drive, you can slide. Right. And again, this is the bracket. So so what is controllability? Controllability here is the same definition is accessibility of x. Means you have access to all the states by your control input. So how you evaluate if this system is controllable? You need to evaluate if this is flowing. Okay. For example, so this is one column, right? This is one column. One column. Next column will be G1. Okay, this is another column. And in this case, it's 3. This dimension is 3. So at least you need to find 3 combinations of this. So next one will be G2, G1, G2. Okay. The only difference between these two is I put G1 first and G2 first. Okay. And here you should get a 3 by 3 matrix. Check if that's full rank. If that's not full rank, don't give up. Try more. Put more. Add it more. Like G1. So the first one will be either G1 or G2. The first one. Okay. Never changes. only two possibilities. And the second one could be you can repeat from the previous stuff. Okay. So all this is trying to say, oh, I use these two combinations of control input, and added one more combination of control input, right? Replace G1 by different combinations and try as small series as you can and see if you got a full rank. If you got full rank, that means you can control, you have accessibility or controllability to any state by using the two control input. Okay? So then, and here, one more thing you need to remember that because this D bracket, the result of this D bracket is a function of x3 and x4, right? So this value, this value depend on the states, right? So if your x3 or x4 is 0, this will be if 0, then this will be 0, and there will be 1, 1, right? So it's 0, 1, 1, 0. So they always changes according to the states. So it's a little bit complicated. So maybe in some states the system is not controllable, 对不对？因为这个 column 的值，某一个 column it depends on the states, right? So in some states, like for example, x3 and 4 are 0, and this one will be 0, 1, 1. So it's 0, 1, 1, 0. Okay, you put 0, 1, 1, 0. So this matrix, in general, will be a function of states. So in some states, it might not be full rank. That means in some states, it's not controllable. 懂吗? So you need to be aware of this. Okay, so that's for the control. That's all for the controllability of nonlinear systems. And here's another necessary condition. Again, necessary, not sufficient. Okay. So the D bracket of f and g cannot be the span of f and g. Otherwise it would not be controllable. Necessary, 必要条件，不是充分条件。Okay. Necessary condition means if this is true, then this will be true. And sufficient condition is the other way. This is true, then this will be true. Okay. Necessary means this is true, then this will be true. Sorry, again. If this is true, then that could be true. Okay. Controllability might be true. Okay. So I think that's for today. Any questions? We have 5 more minutes. 有没有问题? And also, this another property. Another property is if you swap G and F, there will be a minus sign. Okay. That's easy to check, right? So what does this say? It says that if you change the series of your control input, if you apply U1 first, then and then U2, or U2 first, G2, that doesn't change too much because the non-zero elements will be non-zero. The difference is the sign, right? So how do you prove this? Should be easy. And you swap according to the definition. This is definition. Will be f g minus g prime f. So what's the difference? It's only the minus of this will be this, right? So when you swap the two, this you just need to add a negative sign. Okay. 听得懂吗? Okay, that's for today. 没有问题。哪边怪怪的吗？我可以再讲一次。中山有没有问题？
那个
full rank 哎。
确定
啊？
是找到不会再只是说要一直找嘛。
哎。
然后要怎样确定就是
找到下课啊，就考试了你就找到下课，好不好？没有这么，我也不会刻意出那种你找到下课才找得出来，我没那么多时间嘛，对不对 ？So the question is, how did you check? How did you make sure that you don't need to try infinite number of series and to ensure that it's controllable? So the answer is, well, it's you don't need to do this. Okay. Usually, after you check like 1 or 3 times, the answer should be obvious because it keeps repeating the same result. Okay. If, like for example, if this one is 0, 0, 1, and this one is 0, 0, 1, 0, 0, 1, well, I guess you will give up, right? Okay. If you write down all this in the exam, I will give you a pass. Okay. You don't need to find until the exam is finished. Okay. Oh, that's for today. Thank you.